So what if it wasn't so hard to start a lab and to do science and to make an impact? So this is a question that's really at the foundation of Clair Scientific. Science today is a real accessibility problem. So one of those issues is that the cost of equipment is extremely high, and that's a really big problem if you're a new person trying to get started. The learning curve is so high, you either need specialized people to use them, or you need years of training and a PhD, and it really doesn't have to be like that. We have the technology to build instrumentation that is beautiful and simple and fun to use, that can do everything we need it to do. It's a question of putting things together in the right kind of way. We've invented a new way to measure exactly how light bends when it passes through something. And we can do this in a way which is simpler and easier and faster than anything else. And when you can understand how light bends, you can understand what it is that the light is being bent by. You can understand the nature of the material, the nature of the matter you're studying. And that gives you a huge amount of power to understand what you're looking at. And in life science, this is what you're after.
It's the form factor we had because we really tried to push the limit of what was possible to engineer, so we could keep the footprint down and make sure we could save you some extra space on your lab bench.
If we're trying to make something that's not only user-friendly, but we're also trying to make it more versatile, which means that we have an API and you can create your own logics in your own interface, write a Python script, run something that's completely new. So there's a lot of versatility and flexibility and expandability in the microscope.
Finally, for the first time, we actually have the tools to do serious analysis and to do it quickly. And I think the ability to generate more and more data faster than ever is going to be so critical to so many different kinds of science. A big part of that is due to this parallelization that we can do with machines like ours. Once you combine those methods with the capability to produce so many different images across so many different sample types, you start playing with huge dimensions of data space. And these are the sorts of things that we can do when you have a huge amount of data that we never really had access to before. And this is really an exciting new place for science to move towards.